In this video, we're going to cover section 1.3, linear equations in two variables. There's a lot of information, so just, pause where you need to. I'm going to try not to take too long so we don't go over 40 minutes or so. Okay, hopefully it's less, a lot less. So here we go. We have different forms of linear equations. The most popular one is the slope-intercept form, and that is this one, y equals mx plus b. So if we have y equals mx plus b, we know that m represents the slope, also known as rise over run, and b represents your y-intercept, also known as wherever x is equal to 0. Okay, so wherever x equals 0, that's because the graph is crossing the y-axis. We have different types of slopes, and I'm going to go ahead and show you that next. Here we have two. We have positive slopes and negative slopes. Let me focus this really quickly, see if that helps a little bit. There we go. All right, so a positive slope is if going from left to right. So here's my pen. If I'm going this way up, my pen has to slide up. Therefore, this is positive. So in this case, m would be greater than 0. And this is a possible equation, y equals mx plus b. Okay? For a negative slope, well, my pen going from left to right is now going to slide down. So therefore, this is a negative slope and m would be less than 0. So a possible equation for this one would be y equals negative mx plus b. We have two more types that we need to see, and then we can start the actual examples. We have a constant slope. You guys can see that. Let me move this up a bit. We have a constant slope. So the constant slope goes straight across. It's a horizontal line and it goes through a point on the y-axis. I went ahead and just labeled that B because that is actually the y-intercept in this case. So the constant slope has no slope at all. So if you were walking on this, you wouldn't have to struggle. You would just walk straight across, and so therefore m is equal to 0. Since m is equal to 0, 0 times x is just 0, and therefore the equation would just be y equals b in this case. Okay, and finally we have the undefined slope. So this is the opposite of this one. It is a vertical line and it goes through a point on the x-axis. We're going to call it A. Since this is where it's crossing, there is nothing else we can really do but say that x is equal to this number, because no matter what you choose on this line, x is going to be equal to that number. The slope is undefined because if you think about it, it's impossible to walk up a wall straight up and down unless you're like Spider-Man or something, which is probably not possible for most of us. So this has no m and it has no b because it's never going to cross over here either. Okay, so those are the four different types of slopes we're going to see. We're going to go ahead and move on and start with some examples. Okay, so here at the top, I have using slope-intercept to graph. Okay, so we're going to sketch three different graphs using slope and y-intercept. So for the first example, I have y equals 2x plus 1. My m in this case is equal to 2. And if I think of that in terms of rise over run, it could be 2 over 1. So that means I'm going to rise 2 and I'm going to go over 1. So I'm going to go up 2 and over 1, up 2 and over 1. Okay? My y-intercept is 1. So that means that my point there is going to be 0, comma 1, because remember that x is equal to 0 at this point. So what I usually do is I start with the y-intercept. So 0, 1 is right here. 0, 1. Okay, and then from there, I'm going to go ahead and use my slope to figure out some more points. So from here, I'm going to go up 2 because that's the rise, okay, and then over 1, and that's going to be my rise 2, run 1, okay, and then I do it again. So up 2, pretend there's a point there, over 1. You generally want to have at least 3 points. Okay, if let's say you couldn't go off the graph because it was too high, well then you would go backwards and kind of think of it backwards. So instead of going up 2, you would go down 2 and over 1. And to check, we can say, well, from this point to this point, I'm still going rise 2 and then run 1. Okay, so something like that. And this would be a pretty decent sketch. Hopefully, like I said, your lines are straighter than mine. My lines are never straight. And there we go. Okay, so there's a sketch of our graph. Moving on to the second example. In this example, letter B, we have that y is equal to 2. So in this one, this is kind of like the second to last type of slope that we saw. M is equal to 0, so there is no M. Well, not that there's no M, but M is 0. So in other words, it's going to be a flat line horizontal this way. Okay, and our B is exactly what's here. B is equal to 2. Okay, so in this case, our equation is that y equals 2. It's going to cross at 2, and it's a horizontal line. It's a constant slope. Okay. Probably should write that somewhere, okay? And while we're at it, let's go ahead and add this one too. The first example, since it's going from left to right up, would be a positive slope, okay? All right, so back to letter B. So that's about all we can do with that one. It's gonna be across 2 forever. Last example for this one, see this isn't too bad. They're gonna go pretty quick. X plus y equals 2. So the problem with this one is it's not in slope-intercept form. So first, we need to rewrite this. We need to rewrite, okay, as y equals mx plus b. So in our slope-intercept form. So to do that, I'm going to go ahead and move this x over. So I'm going to subtract x from both sides. So y is now equal to negative x plus 2. And now this I can work with. So this right here is my slope-intercept form. From here, I'm going to go ahead and figure out my m. It looks like I have a negative in front. So remember that when there's a negative in front of a variable, you do have an imaginary 1. So this is actually negative 1 over 1 if you want that rise over run notation. Okay, and b is going to be this number. So b is equal to 2. And now it's just like the first example. Okay, so let's go ahead and plot our y-intercept first. So that would be at 0, 2. Okay, so that's going to be right here. Okay, and I apologize for my smoke detectors. They keep going off right now, so you can hear the beeping. But we're okay. All right, so then from here, on my rise over run is negative 1 over 1. So this means down 1 over 1. So from here, I'm going to go down 1 over 1. And there's 1 point. And again, down 1 over 1. And there's another point. Remember, as long as you have like 3 points or so, you're good to go. So I'm going to go ahead and just draw my line. If you have a ruler or something, it'd probably be best to use it here. I'm just being kind of lazy. All right, and there we go. Done. Next examples, or next topic, I guess. So now, where all this gibberish is written, we're going to find the slope of a line. Okay, let me focus this again. Bad thing about this study, and that I do have to focus it myself once in a while. All right, so here we're going to define slope a little bit more than just rise over run, okay? So we know that it's rise over run. It's the change as you go up and then as you go across. So that's what these little triangles, they just mean the change. So this triangle means change in, okay? So this is the change in y over the change in x. We also can call it delta, delta y over delta x, okay? You'll learn more of that if you take a calculus class, okay? So it's defined as the difference between y divided by the difference between x. But in this one, order does matter. So if you put y2 first, then you have to put x2 first also, okay? I have a note over here that these two cannot equal to each other. I wonder why, okay? Go ahead and draw this diagram as well. This goes a little bit more into it. If you have 2 points, okay, we know from previous videos or examples that the distance from here to here can be calculated by subtracting the x's, and this is also by subtracting the y's, okay? So to find our slope, we want to find the ratio of that. In other words, what's the slope as I'm traveling from left to right? What is the ratio of this difference and this difference going this way? And that's where this formula comes from. Okay, that's where we take this value divided by this value. Okay, so we're going to go ahead and jump right into some examples. This should be all review for you so far. We have to find the slope between the following. Okay. So for letter A, what I'm going to do first is I'm going to label everything. So I'm going to start with this one and call this x1. So therefore, this would be x2. This would be my y1, and this would be y2. You notice that I do keep them together. So my 1s stay together and my 2s stay together. I'm going to go ahead and just plug stuff in now. So my slope is defined by subtracting the y's. So 1 minus 0 divided by 3 minus -2. So these two are still together. These two are still together. My y's are on top and my x's are on the bottom. The problem with these is that they're not difficult, but people tend to mix the numbers all up, and we can't do that. You got to keep it where it goes, okay? So from there, 1 minus 0 is just 1. 3 minus -2 is actually 3 plus 2, so this would be 5. So 1/5 would be your slope for this one. So that means if I were to graph it, I'm just going to do this super, super quick. -2, 0 is somewhere right here. 3, 1 is somewhere right here. Okay, so that means that this line has a slope of 1/5. And it looks about right. It looks like it's not too steep. Okay, so it's an easy, if it was a hill or something, it'd be an easy walk. Okay. Next example, and I'm going a little fast only because there is a lot of material in this particular unit. Okay, so for this example, we have -1, 2, and 2, 2. So we're going to do the same thing. We're going to label everything first. So this is x1, this is x2, this is y1, and this is y2. Now, some of you might say, does it matter if I put the x2, y2 first and this one first? Honestly, it doesn't, because as long as you keep it lined up, how, like, the x1 and the y1 together, I'm sorry, x1 with its y1 together, and same with the x2, you should be fine. Okay. All right, so we're going to have m equals, put my division line here. We have x2 minus x1, so in this case, it's going to be 2 minus -1. Okay. And then y, oh, did you already see what I did? It's a good thing I caught myself. What did I do? I started with the x's. So I messed up. Don't do that. That's a good example of what not to do. Make sure that you start with the correct variables. So the variables on top should be your y's. And actually, let me write that over just so we can remind ourselves. See, we all make mistakes. I did that on purpose. That way I could kind of show you how easy it is to make a mistake. Okay. All right. So y2 would be 2 minus y1. So that would be 2 also. Okay. x2 would be your 2 here minus x1. So -1. Okay. And then we would go ahead and simplify this. So 2 minus 2 is 0. 2 minus -1 is actually 2 plus 1, which would be 3. Okay. And 0 divided by 3 is just 0. So that means that my slope here is 0. Let's do a quick graph to see if that's true. So I have -1, 2. That's about right here. -1, 2. And 2, 2. So it's on the same line. And it does look like, in fact, that these go through the same horizontal line because this is a constant slope. So we are good to go. Okay, last one for this section. Let's not go too fast or I might mess up again. We have 3, 1 and 3, 4. So we're going to do the same thing and label everything. So this is x1, x2, y1, and y2. M is defined as the change in y. So we would start with our y sub 2. So it's going to be 4 minus y sub 1, so 1, divided by the change in x. So 3 minus 3 in this case. 4 minus 1 is 3. 3 minus 3 is 0. So this one looks similar to letter B, but except that the 0 is now on the bottom. Is it possible to divide by 0? It is not. So this one, oh, I don't know how to spell, is undefined. Okay. And if we look at the graph, we can plot it and check. 3, 1 is somewhere maybe right here. Okay, so we can say 3, 1 is right there. And 3, 4 is a little bit higher up. But you see how they land right on top of each other, which we know is not a function, doesn't pass the vertical line test. And we also know this is a vertical line. So the equation for this would actually be x equals 3. But more importantly, the slope is undefined. So undefined. Okay, moving on. I'm going too fast. Please, send me an email, let me know, or join some of the tutoring sessions, and we can break it down further if need be. Okay? All right, go ahead and copy this down. This is the next form. It's called point slope form, okay, and it looks like so. Y minus y sub 1 is equal to m times x minus x sub 1. This form uses slope and a point. You have to have at least 1 point, okay? So we're going to go right into an example, and I'm going to show you how to use it. Basically, the point goes here and here. This is where the point gets plugged in, okay, depending on what it is, the x and the y, and then your slope goes here, okay, where the m is located. So let's see how it's used in practice. We have example number 3. We're almost done, guys. We have 5 examples, so we're almost there. Find the slope-intercept form. So remember, slope-intercept form is y equals mx plus b, okay? Slope-intercept of the equation of the line that has a slope of 3. So my slope is 3. That tells me that m equals 3, okay? And passes through -1 and 2. So what I'm going to do is I'm going to label everything like I usually do. This right here is the point, okay? So this is x1, y1, okay? And our m is equal to 3 because they told us slope is equal to 3. So I'm going to go ahead and rewrite this equation just so we can see how it's used, and we're going to plug everything in. All right, so it looks like the y stays the same, so y minus y sub 1 is 2, so I'm going to put it 2 right here, equals m. My m is 3. X stays the same. X of 1 is -1. Be careful here because we already have a negative, so we have to put another one. So there's 2 of them, okay? And that's going to change the value here. At this point, we're just simplifying so we can bring stuff down. So y minus 2 equals 3 parentheses. This becomes positive, so x plus 1, okay? Then we can distribute the 3 into the parentheses. So I would have y minus 2 equals 3x plus 3, okay? And finally, just add that 2 to both sides. I'm going to put it right here so it's not too crowded. So y equals 3x. 3 plus 2 is equal to 5. Okay, and that is it. So for this new equation, my m is still 3, and my y-intercept, also known as b, is equal to 5. So I could graph it if I wanted to. We're not going to do that right now because we already did it, so you know how to do it already. And we don't want to waste too much time. Okay. Be careful because I think some of your homework problems do have some fractions. So if you forgot how to work with fractions, if you need help with that, let me know or look it up and remind yourself how to work with fractions. Okay. All right. Next example, example number 4. This is sometimes called the 2-point form. And here's how it works. It says find the slope-intercept form of the equation of the line that has both -2, 0 and 3, 1. So if you notice, we don't have a slope. And yet we're supposed to use that formula somehow, the point-slope form. But we do have 2 points. And we know from a previous example that we can find the slope using 2 points. So first, we need to find the slope. We need to find m, which is our slope, okay, which is equal to, again, y sub 2 minus y sub 1, the change in y divided by the change in x. Okay, so we're going to do that first. And I'm going to go ahead and actually for this one, I'm not going to label because I need one of these for the next one. So just kind of try to follow me here. If I say that this one is the second point, I'm going to use the 1 first. So it would be 1 minus 0. So I'm looking at my y values. And I can underline them. That's all right. Okay, look at my y values first. Okay. Then I'm looking at the x values. Since I started with this one, I have to do this one first. So 3 minus -2. Okay. And that's going to give me 1 over 5. It should look familiar because we actually did this one already. So my slope is m. I'm sorry, my slope is 1/5. Okay, so this is our slope. And I'm glad it's a fraction because now I can show you an example with a fraction. Step number 2 is to use our point slope. So now we're going to use our y minus y1, okay, equals m times x minus x1 formula. Okay, because I have everything that I need. Now, some people get a little worried because they're like, well, I have 2 points. I only need 1. Here's the beauty about this one. You can choose, oh, I messed with the machine here. You can choose whichever point you want to use. So for this one, if you have 2 points, you want to make a note right here. Choose 1 point for step 2. So this is step 2 right here. Okay, this would be step 1 if you want to write that down. Okay. So I'm going to choose the one that's easiest for me because it just seems to make more sense. I'm going to choose this one because I see a 0 there. Okay, so in this case, if this is the point that I chose, then this is now x1 and this is y1. Okay, so we're going to use those values and this m for this equation. So here we go. Y minus y1 is 0. So 0 equals my m is 1 over 5. X minus -2. Okay, and now we're just going to simplify this. So y minus 0 stays the same. And actually, we don't even need to put the 0 because 0 is 0, but that's all right. So 1/5, this becomes positive x plus 2. Okay, and now in this step, I am going to get rid of that 0 because we know it's not really there. So y equals, let's distribute here. So we would have 1/5 x, okay, plus, here's going to be your side note for the fraction. Okay. 1/5 times 2, okay, is the same as 1/5 times 2 over 1. And when we're multiplying fractions, we multiply straight across. So this would just be 1 times 2 is 2. 5 times 1 is 5, it would be 2/5. So plus 2 over 5. And that would be our equation for this problem, our in slope-intercept form, where the slope is 1/5 and the y-intercept is 2 over 5. Okay? All right, one more example. And it's kind of a longer one, so, good news, bad news, and all that. Here we go. Last section of this 1.3, parallel and perpendicular lines. Let's go ahead and copy these two definitions. We're only going to do one example, or a two-part example, I guess you could say. We should know that parallel lines, when people ask us what they are, they say they're lines that never cross. Okay, so the actual definition is that they are parallel if and only if their slopes are equal. So the slope has to be the same and they have different y-intercepts, because if they have the same y-intercept and it's right on top of each other and it's no longer parallel, they're equal to each other. They're exactly the same line. So our slopes have to be the same. That's the big idea I want you to get from here. Okay. For perpendicular lines, it's kind of the opposite. So perpendicular lines are perpendicular, and I forgot to underline that, if and only if their slopes are negative reciprocals. So not only do we flip it, but we also change the sign. So if my slope was, here I can give you a quick example of that. If m was equal to, let's say, 5, okay, the reciprocal would be, and let me show you a cool trick with this. This is the symbol for perpendicular because of the little right angle, okay? So if I needed to flip this, well, I'm going to put it over 1 first, okay? I flip it, so it's 1 over 5, and I just make it negative, okay? So this symbol, we would have our original on this side and our negative reciprocal here. So this would be the negative reciprocal of 5 over 1, okay? All right, that's all we need to know to do this last example. Example number 5. Okay. Find the slope-intercept form. So remember, that's this one, y equals mx plus b. Make sure you know your forms, okay? Of the equations of the lines that pass through 2, -1, and are A, parallel to this equation, and B, parallel to the same equation. So we're going to start with letter A. And notice that we have, okay, so we have a point, we don't have a slope. So it looks like we could probably get the slope from this one if we fix it. So I'm going to go ahead and rewrite this first, okay? So first, we're going to rewrite as y equals mx plus b, which is our slope-intercept form, okay? So in this example, if I subtract 2x from both sides, I would get -3y equals -2x plus 5. Okay, divide both sides by -3. Make sure you divide every single term. So y equals, right here, you can't see what I'm doing. Right here, we have -2 divided by -3. We're going to leave it as a fraction. So 2/3 x minus 5 over 3, because this positive and negative make a negative. Okay? So this would be the slope-intercept form, which I'm also going to use for part B. Okay, but I got to do it at least, I got to solve it at least once. And all that I want from this is the slope. So the only thing you want from here is this. So m is equal to 2 over 3. Okay, and now we're not done. We want to find the equation that is parallel to this line. So this is a line, some line on a graph, right? It has to be parallel to this and pass through this point up here. So to do that, well, we're going to use the point slope formula because we have a point and we have a slope. So now for step 2, now hopefully I can fit this all here. Okay, for step 2, we're going to use the point slope formula. So point slope, it's going to put point slope. Okay, which again is y minus y1. I'm not going to color code this time. times mx minus x1. Okay, so let's go ahead and plug it in. We have y minus, our y1 is going to be the point that's the value up here, so -1. So -1 is equal to 2/3, because that's our slope, parentheses x minus 2. Okay, I'm going to do several steps here. So this is going to be y plus 1, because the two negatives make a positive. And I'm going to distribute this here. So I'm going to get 2/3 x, and then 2/3 times -2. Remember that all we're really doing is putting this over 1 and multiplying straight across. So that would be 2 times -2 is -4. And then 3 times 1 is 3. Okay, hopefully you're still with me. Now here's where that more fraction work happens. So we have to deal with this -1 still. So I'm going to subtract 1 from both sides. Okay, so now I have y equals all this. Y equals 2/3 x minus 4/3 plus 1. But you have to combine this. You can't just leave it like that. So here's where we have to change this 1 to a fraction. I'm going to change it to a fraction of 3/3. And I'm allowed to do that because, and see, where can I put that? I'll put that right here. I'll put a little side note here. Okay, so 1/1. Okay, if I multiply the top by 3 and the bottom by 3, it's still equal to 1, but it's going to be 3/3, which if I divide is equal to that 1 right here. So we're just finding a common denominator so that we can add these fractions. Okay, so in the end, we have y equals 2/3 x, and I'm almost out of room here. And I'm looking at the fractions here. So for these fractions, and that's kind of messy, we have a denominator of 3, and then we have the top, -4 plus 3 is -1. So I'm going to put that minus right there. And this would be our answer for this one. Okay, if you got lost here in the fraction work, let me know. All I did is I changed this one. So I changed to 3/3 to find to have a common denominator, and then I just combine the top, the numerator. -4 and +3 is -1. Okay. All right, that was the easy one, sort of. Here's part B, perpendicular to the same line. So we know that this is the same as y equals 2/3 x minus 5/3, and that's from this part right here. Okay, so again, all I really care about is the slope, but remember that for perpendicular, we have to flip it. So I'm going to go ahead and do my little symbol here. Okay, and the slope was 2/3, so 2/3. So if I flip this, I'm going to have 3/2, and I have to make it negative. So this is the slope I'm going to be working with now. This is the slope that would be perpendicular to the original line, meaning make a perfect 90-degree angle with it. A little bit of geometry in there. Okay, so just like the one before, we're going to go ahead and go right into step 2 and use our formula. So y minus y1 is equal to m times x minus x1. Okay, so see, we're not too bad off. We're just probably going to have to deal with those fractions again. So y minus, our y1 is the same as the one before. So it's that -1 that we saw earlier, okay, is equal to m. So our m is -3/2, parentheses x minus, our x1 is 2. Okay, let's simplify. So this is going to be y plus 1 is equal to, if I multiply here, oh, this is going to come out actually really nice. So this is going to be -3/2 x And then if you think about this, if I put that over 1, okay, -3 times -2 is +6. Okay, 2 times the 1 is 2, and we can divide this. So let's divide it so we don't have to worry about those ugly fractions. Y plus 1 is equal to -3/2 x. 6 divided by 2 is 3. Okay, subtract the 1 from both sides. So y is equal to -3 over 2x. 3 minus 1 is +2. Okay, and that is it, sort of. Just because we can, if I were to graph this, and I'm gonna see if I can zoom in on this part. Let's see. And this is just a super, super quick sketch, okay? So if I were to, mostly because it's a fit, if I were to graph this really quickly, okay? Well, this one, it's starting at -1/3, so it's somewhere right here. And the slope is up 2/3, so it's probably gonna be like up 2/3. I don't know, something like that. It's gonna be pretty not steep. Okay, so something like that. Okay, that's this line right here. This line is starting at 2, so it's up here somewhere. And the slope is -3/2, so it's going down 3/2, so something like that. Actually, probably steeper, probably something like this. Okay. The idea is if you graph these correctly, okay, because obviously this is just a quick sketch, you're going to make a perfect right angle here. Okay, because this is a perpendicular line, and perpendicular means that these are going to be perfectly angled at 90 degrees, and the definition does come from these reciprocal slopes. Okay, all right, but that's just a little bit of extra information. So if you have any questions, as usual, let me know. Thank you for watching.